Hello and welcome to MLOps Minutes. In this episode, I'm going to talk to you about library versioning. In MLOps best practice, we want the generation of your model, our model, to be reproducible. One of the keys to this is library versioning. In most languages, library numbering uses semver numbering with a major, minor, and patch number. What does this mean? If we increment the patch number, it's usually when we make a fixed bug that is purely internal and has no impact on the consumer. We'll update the minor number, generally when we're adding functionality that doesn't impact the library's main interface. And if we make a breaking change that will break the library's interface, the consumer will be obliged to update his code at the time of the update. The major number will be incremented. In Python, this more or less respects semver, bearing in mind that it's quite permissive and the library authors don't necessarily respect the Python format set out in the documentation. Generally, you will find libraries in this numbering format with 0, 9, 10, 1, 0. It is possible, for example, to have alpha versions postfixed with a small a and a version number, small b for betas and their beta number, and small rc with the release candidate number. There are other small specificities, but we won't go into detail here. Now back to our MLOps Python project. Here we have packages that can be reused between training and production. And I have my inference package, which in this example has a requirements.txt file on which you can run pip install our requirements.txt. Here I have libraries where version numbers have been specified. For example, here TensorFlow equals 2.12.0. What happens is that quite often you'll see in your projects or in certain projects numbering like this, where TensorFlow equals 2.12. And this means that when we do a pip install, we're asking for the latest version 2.12. With the latest patch number. So there are equivalent notations. For example, here, if I type tilde equals 2.12.0, it's equivalent to the annotation above. I can also request TensorFlow greater than or equal to 2.12.0, comma, strictly less than 2.13.0, and that does exactly the same thing. It also works with the release number. In other words, I can automatically, the latest release version, the equivalent with the equal tilde is 2.0. The equivalent with chevrons is greater than or equal to 2 and strictly less than version 3. That way, I'll always have the latest release of TensorFlow. Now, the problem with doing this is that if I pip install of my requirements.txt file today, and tomorrow I pip install my file again, what's going to happen is that I'm not sure I'll have exactly the same version of the libraries. And that's a real problem, because it means that if I'm training, I'm generating a model at a given moment. And tomorrow I want to regenerate my model. I'm not sure it's going to work, because I won't have exactly, and I'm not sure I'll have exactly the same libraries. So you tell me. I can go back to my notation from the very beginning, i.e. by freezing the version of TensorFlow. Well, I still have a problem. I still have the same problem. Maybe TensorFlow itself uses little ideas, little stars or chevrons. So when I pip install my libraries, I'm still not sure I'll have the same version today and tomorrow. Fortunately, there are some superb open source tools such as Poetry or pipenv. In my case, I'm going to show you pipenv, which allows us, let me explain. This is a pipenv configuration pip file. We'll be able to enter the version numbers we expect from our libraries. You can put tilde, you can put chevrons. But what happens is that if I do pipeenv install the first time, what will happen is that pipeenv will retrieve the libraries, install them, and above all generate a pip file log file here, which will be a snapshot at a given moment of all the libraries I've retrieved. That is, even the underlying libraries used by TensorFlow. So if tomorrow I come back to my project, I can do pipeenv vsync. As a result, the installation won't use this pip file, but the pip file lock directly, and it will download exactly the same libraries as when I generated the pipfile.lock. The good thing is that we're now going to push this file into Git, into the version manager. When we launch a continuous integration, we'll be able to do a pipenv vsync, which will enable me to have exactly the same libraries. And later, if we want to regenerate our model from the code we had at one time, we'll be sure to have exactly the same versions as back then. By doing this, I'm well on the way to making my model generation reproducible. And that's great. Thank you and see you soon for more videos.